Hello Java programmers. Let's talk about GUIs, graphical user interfaces. Life would be a lot less interesting if everything we did was text-based. These days, when you turn on a computer, at least a personal type computer or device, you expect a mouse pointer and you expect graphics. And if there's no GUI, you might get a little bit upset. There are still plenty of things that we do from the command prompt rather than from a graphical user interface. But for the most part, end users expect a graphical user interface. You could spend your entire career writing programs that don't have user interfaces. You could do database programming or web-based programming on the back end where you're managing the data and you're responding to the user requests. Or you could spend your career developing user interfaces that are graphical. So it's a good idea to have some feeling for what tools are available and what constitutes an effective tool or maybe a not so effective tool for developing a GUI. So we're going to look at some tools that are available in Java, particularly a tool called Swing, which we consider, I guess, a framework. And then we'll talk about maybe whether that's a good tool or not, and whether there are some other options. But your takeaway from this is that, yes, I can create a graphical user interface with what's available in Java. However, it might not be the best way to get things done in this modern environment that we live in, but it will still give you a good background. I'm going to close my PowerShell because I opened that as an example of a text-based shell or a text-based user interface. Just to show you that, sure, while we still do a lot of things with the GUI, there are some very powerful shell text-based interfaces as well. So I encourage you to, once in a while, push yourself away from that mouse and learn how to do things from the command line or the command prompt, because in many situations you can be more efficient, especially when you're dealing with bulk processes. If you need to do something to a large amount of data, or you need to do something to a large number of computers, if you're a network engineer, then a command line shell is often a very effective tool as opposed to a GUI. But that's a little bit of a tangent. We'll get rid of that now and we'll move on to our topic of the day, and that is Java and Swing. We're going to be importing another set of classes, generically referred to as Swing. And the X in Java X stood for extra, meaning that it was not, strictly speaking, part of Java, but for our purposes we will consider it part of the quote-unquote language, and we'll assume that those classes are available to us. So let's create a plain old vanilla Java project. And we'll just call this Swing Stuff. Since we don't have a lot of context, we're not creating a solution to a problem. We're just demonstrating concepts. Nothing has changed to this point. This is what we've always done. We have an empty project. Now, in a production environment where we're creating user interfaces for real people to use to do real work, it's extremely unlikely we're going to start from an empty project. But we can still demonstrate important concepts from this perspective. And let's just create a new class. And for lack of a better term, we'll call it main. Whoops. We will have Eclipse create the main method for us. We're not going to do as much modularization in this project. We could, but we'll just keep everything in one class. We'll be writing a few methods here and there. Refer back to the slides. And let's just grab that import statement. You know where that goes. I usually put it right below the package and then right above the start of the class in that module. Don't forget there's important stuff here at the top. You know what that is. Now this project knows about things that Swing can do for us. It knows about some classes that are part of the Swing library. The first thing we'll do is create a J-frame. The J-frame is going to look very familiar to you. Again, take it right off the slide. We'll put it in the main because it is an executable statement. And that is declare and instantiate. Whoops. But nothing is displayed yet. It does exist in memory. It's just not showing up anywhere when we run the program. If you were to run it now, it would run. It doesn't generate any output. It doesn't generate a graphical user interface. It just happily completes without doing apparently much of anything. But on slide 4, we're going to get a little bit closer to displaying this thing. We're going to do a couple of configuration changes to our frame. How do we want our frame to behave? And as you think about writing a GUI, all the things that you expect a window to do, all the things that you expect a graphical user interface to do are available to you programmatically now. If I want this J-frame to have a title bar or not, if I want it to be a particular size or not, if I want it to be resizable, if I want it to have a background color. So all those things that you come to know and love in a traditional GUI, you can do programmatically. The challenge that you're going to face then is how to figure out what the programming statements are to cause those things to happen. And I'll just introduce a few of them here to get your mind going in the right direction. One thing that we do quite often is we make the decision that when our GUI closes, we want the entire application to close. Now that may not always be the case. Again, that's a design decision. In this case, though, we're going to say that when the user clicks the red X or any other technique that closes that frame, then I want the entire program to finish. And that would be analogous to Microsoft Word. When you close the documents, then Word closes itself. Or PowerPoint, or probably most video games. When you close that window that you're playing around in, the application closes. The next thing I decided is that I want to give it a particular size. It's always good to have control over your GUI. And I've decided this should be 400 by 200. Those numbers are pixels. As a developer, you would look at the requirements for the app that you're developing, the program that you're developing, and you'd say, well, 400 by 200, that's a good starting size for whatever program I'm developing, and I'll just go with that. And that becomes your mindset. How do I want that frame to behave? And what programmatic commands do I have to execute to make that happen? Are we going to memorize all of those commands? Absolutely not. But we should know by this time that we can Google things. If we can characterize the problem reasonably well, we can find the commands that we need to make this behavior happen for us. And I'm, again, just going to take these lines of code right off the slide. They go in the main, and you're going to have to follow along very carefully with me because I'll be pasting things in different spots here and there. Obviously, the order in which things happen matters, so be careful to paste things and copy things in the same places that I do. And I'm just going to fix some indenting. All right, our program now has 3 lines. They're all in the main. The first line instantiates after declaring, and the object type is JFrame. Now we don't know what a JFrame is. It's obviously some kind of class. You've seen the syntax before, but you don't know all the ins and outs of a JFrame class. That's okay. We now have an object called frame. The object is of type JFrame. We've seen all kinds of other objects before. This is a new kind of object. We've seen that we can define the behavior of that object when it is closed. When the frame is closed by the end user, then the program itself will finish. The entire main will be done, and then you'll be back to Eclipse again. Now there's a problem. You can see dimension is underlined, and I did this on purpose. We're going to use other classes in our GUI. Classes are going to be coming and going like crazy. And the way that we define the preferred size is by using a dimension object. That's okay. Don't have to worry about how it works or why it works. All you have to know is that when you create this dimension object, you put in rows and columns of pixels. So 400 by 200 pixels. If you're not sure which is the rows and which is the columns, is it 400 columns, 400 rows? Don't worry about it. If it's not right, just swap those two numbers and then run it again. There's a tremendous amount of trial and error when you're doing graphical user interface development. Did I locate that button in the right place? Is that background just the right shade of pink? You try it, you run it. If it doesn't look right, you tweak it, you run it again. It's an iterative process. Don't expect it to be perfect the first time, because I guarantee it will not be. So I'm not even going to tell you which is the rows and which is the columns. Okay, I'll tell you. 400 rows by 200 columns. Anyway, there's an error because it does not know what a dimension class is. And remember, the error message, dimension cannot be resolved to a type. Wherever you see the word type, think class. A class is a data type, and Eclipse shortens that to type. What they're saying there then is you're referencing some kind of data type called dimension, and I don't know what that is. I haven't seen that before. That means it's not in javax.swing. All the classes that we dragged in with that import statement, none of them are dimension. Now, how did I know I needed a dimension here? Well, I just read it in a book or found it on a website. It was not magic. I didn't wake up knowing that this morning. I found an example of code that demonstrated how to set the size of a frame, and I used it. But the problem is that I have to provide a definition of this dimension class or this dimension type. Eclipse, being so helpful, offers numerous suggestions. The first one is correct, the one on my screen, import dimension. And I know that's the correct one because I'm telling you it is, and I've done it before. The other ones don't make a lot of sense. The second one, create your own class called dimension. Well, there's no logical reason to do that because you wouldn't know what went in that class. The next one says, here's a class that I already know about called dimension2D, and that is in java.awt.geometry. Now, AWT is Abstract Windows Toolkit, and that is another set of GUI tools. And that's kind of tempting. Well, maybe I just typed it incorrectly. Maybe I meant to type dimension 2D. And maybe if I change it to dimension 2D, the error will go away. That's not sufficient, however, because making the error go away doesn't mean we fixed our program. The third fix, again, is a guess on Eclipse's part. Change to dimensions node. And then in parentheses, it tells you where it found the definition of that type, org.graalym.compiler.hotspot.nodes, which none of that looks familiar to us at all. You may not even have that on your screen. That may be a function of something I installed 5 years ago. That may be a Java library that I have that you don't have. So your list of quick fixes might even not look like mine. But I will tell you that it is the first fix, import dimension, and what it's going to do is reference java.awt, the Abstract Windows Toolkit. It adds an import statement. In my program, it added it in what's now line 4. And that's great. I can clean that up a little bit, group those imports together. I can collapse them. Remember, that becomes a collapsible section in your code, and that's simply a function of the Eclipse text editor. That has no effect on the execution of the project. It simply collapses a whole bunch of statements that you don't need to look at. And if you've got 100 import statements in a module, it's very convenient to collapse them into one statement. They're still there, you just can't see them. Now we have some basic behavior defined for our frame. It's still not going to appear yet. You can still run this, however, as we saw earlier, you won't see anything. There's no output to the console window, and there is no GUI. On the next slide, however, things get more interesting. Finally, we're going to display this frame that we worked so hard to create and configure. Copy those two lines of code right off the slide. This is slide 5, and I'm going to put them below everything we've done to this point. Remember, these things do need to happen in a general order. The instantiation declaration comes first, and then the definitions of the behavior, and then finally, after we've got everything the way we want it, we call set visible on the frame with true. You probably already realized that will finally show us the GUI. Let's go. Here we go. I can't stand it anymore. Let's run it. There's our frame. We are beginning to create a graphical user interface. That looks a lot like 99% of all the other programs we've ever run on our computer. I'm on a Windows machine. That looks like a Windows window. And now you can see that the term JFrame, the type JFrame, represents a window in Microsoft Windows. If you're running on a different platform, Linux or Mac, it may look a little different, which is good. We want something that looks similar to what everyone has already seen on their machine. That way the programs that we develop in Java fit into the visual experience of all the other programs that people run on their computer, which is kind of neat. Let's go back and review what we've just done. I'm going to count the lines of code. 1, 2, 3, 4. We wrote 4 lines of code, and we got a window with a minimize button, a maximize button, a close button, a title bar. It's sizable. It can be dragged around the screen. And it looks just like many other things that we've seen before when we run them on our computer. Very exciting. So in 4 lines of work, we got all this done for us. And that's the power of these libraries. You can't imagine how many hours and days and weeks and months it would take to write this from scratch. I wouldn't have the first clue how to create a window and make it sizable and draggable and minimizable and maximizable and closable without having these libraries at my disposal. Very exciting tools. Slide 6. The next thing that we want to do is give ourselves a place to put controls. A control is anything you put in a window, a button, a drop down, a checkbox, a text field, a label. As you get better at this and gain more experience, you're going to learn that there are some generic names for controls, say a label, but the classes that represent those controls might have slightly different names. We've seen already that a JFrame class represents a window in our operating system. Now we're going to see that there's something called a Jpanel, and a Jpanel is a container. That's all it is. And we'll plop other controls into that container. Containers are great. The concept of a container is incredibly powerful because we can group things together and move them as a group, or hide them as a group, or resize them as a group, or change their layout as a group. We already have one container, and that's the JFrame. We're going to put another container into that, and I'll refer to that generically as a panel. You can see from the line of code on slide 6 that a panel is represented programmatically in Swing by a Jpanel. And let's just grab this code right off of slide 6. And I'm going to paste it below. Actually, be careful now. I'm not going to do that. I'm going to paste it above the set visible. So I'm going to put it right between the pack and the set visible. The pack is a command to resize the frame according to what is currently in it and what size you would like it to be. So I'm going to leave the pack alone because it worked great for us and there was nothing to pack anyway. It just packed it down to the preferred size. And I'm going to paste the instantiation and declaration of that new control, that Jpanel, above the set visible. All right. And we're just doing these things so it's conceptually easy to follow. The thought process is that we'll create our frame, configure our frame, add things to the frame, and then finally display the frame. It kind of makes sense flowing from top to bottom. At this point then we've created the frame, we called it frame. We set the size of it, we packed it, which shrunk it a little bit down to 400, 200. Then we created a new control called a Jpanel. We called that panel. Finally, well not finally, but next, on slide 7, we will add things to the panel. Keep this all straight in your mind. The frame contains the panel. The panel contains, or is about to contain, 2 labels and a button. One container contains another container, and that container has 2 labels and a button. Grab the code off of slide 7. Paste them in right below where you instantiated the panel. I do a little bit of cleanup here to line up everything. Looks like the quotes are off, so you may have to fix a couple of quotation marks in the code. If you've caught up with me at this point and you fixed your quotation marks, you pasted everything into the program, you'll see that I introduced another error. And again, this is just to make a point of things that happen to you as you're developing and things that you need to fix. I want to add 2 labels to this panel. The first label I called label. In line 22, declare and instantiate. And that's great. But in line 24, I decided to add another label, and I mistakenly used the same name. I can't redeclare something called label. I've already got a thing called label. So I need to fix this, and I'll just call this label 1. And I will go down to the next line and change that to label 1. So now I have, let's go through this code carefully, a declaration of an object called label, and that is of type JLabel. I'm using the JLabel class to create a label object. And then in line 23, I'm adding that to the panel. And there's the concept of a container. The panel object contains the label object. And this will manifest when you display the frame. You'll see that one thing is contained inside of another. The next thing I did was create another label, same data type, JLabel. Now we've declared many variables over our time together, and this is just another variable declaration. So instead of using int or string or boolean or float or double, we're just using JLabel. It's another data type. This label is going to contain the string label space 2, label 2. Add that one to the panel. Remember, at this point, nothing is showing up on our screen. As this program is running, there is no GUI visible. We're building the GUI behind the scenes, and then magically we're going to show it all at once. The next thing I do is create a button, declare and instantiate using the JButton class. My variable name is button. The button will have a label. As you realize that whenever you click on something on a screen, it has a label on it. Notice that we're learning all kinds of terminology here. A frame is a container. A panel is a container. A label is of type JLabel. A button is of type JButton. A button has a label. Now all of those terms are going to vary slightly between GUI libraries and between development platforms. If you begin doing this kind of work in C# or C++ or Python, the philosophy is pretty much the same. Containers and frames, but the terminology is different. Now that's perfectly okay, and we can't change it anyway. All we have to do is be able to mentally adapt, and once we understand the concepts, we can figure out what the actual terminology is in the particular language that we're developing in. All of this stuff really does apply across platforms, just slightly different verbiage. Things are getting exciting. I've added 3 controls to my panel. Now, is the panel contained in the frame? So do you see anything on here in my program that says that the frame knows that it contains the panel? Well, I see an add where I'm adding the button to the panel. I see an add where I'm adding the label to the panel. But go back to the slides again. Do you see anywhere where I'm adding the panel to the frame? Remember, we're thinking container, container, container. We stopped on slide 7. We were copying and pasting code from line 7. What happens if I run this? Am I going to see my labels and my button? Let's find out. I don't see it anywhere. I have a problem then if I was expecting something different. I have to back up now and stop and think, why don't my labels and my button appear on my frame? And the answer is that I never added the panel to the frame. I need to back up then and think about how to solve this problem. The first thing you're going to want to do, be very careful, is to close that frame. If you don't close the frame and you simply click off of it and you go back to Eclipse, then the app is still running. I can see down in my tray that I have that frame. And I also have visual cue in Eclipse. Remember that red button is lit in the console tab, meaning that my app is running. And I can click the red button and kill it, or I can load the frame back and kill it that way. But I have to terminate that, or I'm just going to have 17 instances of this running at the same time, and I'm going to be very confused. Be careful then to close the current execution of the app before you start making changes to run it again. Click X. Now you're back to Eclipse. There is no running instance of your app. But I need to say frame dot add panel. So tell swing that my frame contains my panel. Let's see what happens. I just added that one line of code. Oh, look at that. Now I have my labels and my button. You can't see the panel. If you don't make any specific changes to the characteristics of the panel, it's invisible. It's simply a pure container. Now we can make it have a border. We can make it have a background color. So you can do some visual things with a panel, but for our case, we're just interested in having it behave as a container. The panel's there, you just can't see it. And that looks kind of neat. Before we do anything else, resize it. You'll see that if you make it small enough, you can actually cause the button to drop down below the labels. And if you make it larger, those two controls, those three controls, two labels and a button, will persist to be in the center top of that frame. And that's a function of what we call layout. We're not going to spend a lot of time on layout, but I just want you to know it exists and that you may have to spend some time on it. If you start doing this work in production, you will have to be well versed in layouts and understanding how to use them. But for now, let's just get out of this execution again. So click the red X, the close button, kill the frame, back to Eclipse again. If you look at the slides, slide 8 mentions that we are in what's called the flow layout. That is the default layout for a panel. When you start putting controls into a panel, the default is that they will flow one after another, top to bottom, left to right. And as you resize the panel, and I did that by resizing the frame, then those controls will automatically move. And that is a very flexible and useful layout, depending on what your intent is for the GUI. So a lot of times that layout is effective and you can leave it that way. I provided in slide 9 a link to a very valuable tutorial about layouts. Layouts are a topic in and of themselves. We could spend weeks and weeks just discussing layouts. Your takeaway in this video should be, yes, the layouts exist, and there are different ways that I can ask Swing to manage the appearance of controls in a container. Sometimes you just give up and you hard code in your program exactly where you want controls to go. A row and column of the upper left-hand corner of each control. So no matter what the size of the frame is, I want this button to always be row 100, column 200. Or sometimes you use one of the more flexible layouts, as we just saw, the flow layout, for example, and you let Swing manage the locations of all those controls. We're not going to go into any more detail than that. Another important topic in GUI programming is called event-driven programming. This is a new concept for us. Instead of calling our methods, instead of invoking our methods, we're going to let Swing do it. We're going to write some code, and we're going to tell Swing, when something happens, call this code, invoke this code. This is a crucial part of software development anymore. You can't ignore it. You have to understand the concept of event-driven programming to be an effective developer. It's not just a GUI-specific concept anymore. from the perspective of graphical user interfaces, there are events happening all the time. When you pick up that mouse and you move that mouse, you're throwing off hundreds and hundreds of events. When you click the mouse, you're throwing off an event. When you resize a window, you're throwing off an event. You have the capability to hook into those events and run your code when something happens. In effect, you're saying to the operating system, let me know when someone clicks on this button. Let me know when someone resizes this window. And it goes beyond that. It goes to files. Let me know when someone deletes a file. Let me know when you're shutting down so I can do something. And once you understand that concept and you study the available events, you can have your program do all kinds of neat things behind the scenes. Right now, we're concerned about probably the most popular event, the event that most of us learn first, and that is the click event on a button. Every program that we use has buttons. And when we click on a button, something happens. And you know, as a developer, when you click on a button, there's some code running. I mean, that's how things happen as code executes. So we need to understand how to write our code such that Swing calls our code when the event takes place. That's event-driven programming. And when you pick up a GUI tool, we picked up Swing today, one of the first things you want to know is, how do I hook into the click event of a button? How do I do that? How do I make my code run when someone clicks on a button object on my GUI? One way to do it is with the add action listener method. So the terminology in Swing is that action means event. We talked about all the events that happen. There's an event when you double click. There's an event when you resize a window. There's an event when Windows shuts down. There's an event when you minimize or maximize a frame. They are called actions in Swing. Again, there's a difference in terminology that we have to be able to comprehend and adapt to. What we're saying here on slide 11 is that when the user clicks on the button, we're going to execute a method called show message dialog, and that will just print a message on the screen and wait for you to click a button to close that little window. Now, a Option Pane is another class in Swing, so it's another data type, and all it does, and I'm using the word all as an understatement, all it does is put up a wonderful little message inside of its own dialog window with an OK button and wait for you to click on it. Therefore, with one line of code, as you see on this slide, we can generate a dialog window and make everything stop until the user acknowledges it by clicking on OK. Let's take this code off the slide, and again, you've got to be really careful where you put it. Back in our code, as long as Eclipse knows about the button, we can stick that code in an appropriate place. So button comes into existence where? Right there. Declare and instantiate an object of type JButton, and the object is called button. Now, right below that, let's paste in the code from the slide. And we're saying that when someone clicks on that button in the GUI, execute the code in line 29. We're hooking into or connecting to the click event of that button. And we can do all kinds of things to clean this up. Formatting can sometimes be a little bit weird on these functions the way they're written, so I'm going to just, for the sake of brevity, smush all of that onto one line. This little arrow that you see in line 27 is called a Lambda function, Lambda. I'll add a comment here. Use a Lambda function to define what happens when the button is clicked. We haven't discussed Lambda functions, but now you have seen one, and wherever you see that little arrow, which is actually a hyphen followed by a greater than sign, it's 2 characters, that's what's called a Lambda function. And I encourage you to take some time and read about those. They're not a simple topic. They confuse a lot of people, but using them isn't that bad. All right, we've added one line of code to our project. Let's see what happens when we run it now. The GUI doesn't change. The GUI looks the same. We have label, label, button. We're still in flow layout. If we resize the frame, the layout manager automatically moves the controls, which is kind of neat. When I click the button, though, we've now hooked into that click event. There's that dialog box that appears, and it is a true dialog. You can't do anything else in the application. You can't close the JFrame. You can't go back to the JFrame and do anything. This dialog box has taken over the control of that app. Until you click OK, you're stuck in that dialog. Now we're back to the JFrame again, and we can close it if we like, or maximize it, or minimize it, or whatever. And I am going to close it. Go back to your code. You can see that in, what, 10, 15 lines of code, we've written a tremendous amount of Windows programming. We don't know anything about Windows. We don't know how they resize. We don't know how they slide around the screen. We don't know how they open and close. But by using the Swing library, we can take advantage of all that functionality. Let's go back to the slides. In slide 12, it's time to do a little bit more interacting with our user. Right now, the user can close the frame, drag it around, resize it, and click on our button. We'd like the user to be able to type in some information. Swing has a control called a text area. Now, if you've used Windows for any amount of time, you probably think of this as a text box, perhaps, or maybe you have a different term for it. And that's okay. It's just different terminology between different frameworks. The Swing framework refers to that control as a text area. And one of your jobs as a developer is simply to adapt to the different terminologies. Let's grab this code right off the slide. We're going to paste it into our project carefully. Let's paste it right above the frame.add. Clean it up a tiny bit. What does this new code do? Hey, we're creating two objects of type JTextArea, which are text boxes. We're defining them to be 1 row and 30 columns. That's a function of the default font that the GUI knows about. So this number of pixels is going to vary based on what font the text area thinks it's using. I'm not concerned about the font right now. I'm going to say, okay, Swing, you decide how many pixels that should be, but I need 1 row of typing and 30 columns of typing in each text box. That's our trial and error coming back into play again. Sometimes you just have to go back and say, hey, that wasn't enough. I need to change the font, or I need to change the number of rows and columns, or change the behavior of the text area somehow. And if we were to look at the text area or JTextArea class, we would see numerous ways to configure the behavior of that little guy. Make him bigger, smaller, change his background color, change his font, give him a shadow, make him chiseled, give him a foreground color, all kinds of neat things. Finally, after creating those two objects of type JTextArea, we add them to the panel. How about that? Notice the order that we did things, particularly the order that we added things to the panel, is going to affect the layout. We put 2 labels in. That's the first thing we did. We added 2 labels to the panel. Then we added a button to the panel. Then we added 2 text areas to the panel. When you run this, that's the way they're going to appear in the flow layout. There they are. Label, label, button, text area, text area. And that's because we're using the flow layout and we're letting flow decide where to put things, and flow decides where to put things based on the order you added them to the container. Okay, again, just trial and error. You learn these things as you practice. If I resize the frame, you can see that when the frame gets wide enough, the flow layout causes those 2 text boxes to appear on the same row, or the same line, I guess, as the other controls. Flow layout. If you don't like that, if you think flow layout is horrible and you don't want to think about it that much, then look at the other layout managers and you can see many, many other ways to cause your controls to get laid out. I killed that app now. I'm back to Eclipse. The app is no longer running. And if you look back at the next slide, which is slide 13, here's how we can read from the text areas. We call the getText method on the object that we instantiated. Our variable, our object, is called txa number 1, and the other one's called txa number 2. So let's take those 3 lines of code. Now we have to be very careful where we put these. Very careful where these go. When do we want our program to read from the text boxes? Remember, events. Everything is based on events. What event should cause us to want to read from the text areas? And sometimes I call them text boxes. That's a more generic term. When is that supposed to happen? And that's going to be up to you. You decide when you want to read from the text boxes. Well, in this case, we want to read from the text boxes when the user clicks on the button. That makes sense. Usually somebody types in a bunch of stuff and clicks on a button. That's what we want to happen in our program. And that's great. We just have to put it in the right spot. Now the right spot is going to be part of this Lambda function. So I need to break this up again. And I'm going to just blow away what I already had in there and paste in everything off the slide. Here we go. Control V, paste. That was right from slide 13. Okay. There we go. Now, when the user typed into the text boxes and then decided to click the button, the code in lines 30 and 31 will execute, but we have a problem. Do you see the problem? Java doesn't know what these are. It doesn't know what TXA number 1 is, and it doesn't know what TXA number 2 is. And that makes us sad, and maybe we should look at a different career, maybe Amish farmer. Maybe this is just too much for us. We take a deep breath. We realize that we declared and instantiated those variables below the Lambda function. So those need to move. Let's just move them. All right, I'm going to cut those 2 lines. And I'm going to put them above the reference to the Lambda function. And there it goes away. Now it knows what those are because it has seen them before they are referenced. It knows about the declarations. I didn't change the add. The add is still down below, so I added the button to the panel before I added the 2 text areas to the panel. So far, so good. If you look closely at the code in the event handler in the Lambda function, we ain't doing much. We're extracting values from the 2 text areas. We're storing those values into strings, num1 and num2. That's all we're doing. We're not doing anything else. All right, that means the GUI still isn't very exciting. So let's go ahead and go back to the slides and see what the next step is. The next step is to convert those 2 things that we grabbed from the text areas into numbers, integers in this case, and then add them together and then put them back into one of our labels. In this case then, I'm on slide 14. I've already got the first 2 lines of that slide in my event handler. I don't need those again. I'm only going to grab the last 3 lines. Those come right off the slide, go right back to our code, and underneath, but still inside the event handler, I'm converting those 2 strings into integers, storing them in A and B. I'm adding A and B together because I can add integers. I can't add strings numerically. I can only concatenate them. I'm converting it back to a string, and I'm storing that into one of my labels. Remember, I have this thing called label that I made about half an hour ago? The upshot then of all this hard work is the user types in 2 numbers, clicks a button, I read those 2 numbers, I add them together, and I put them back in the label. I've created the world's dumbest, simplest calculator that is very trusting and can only add 2 numbers together. But it will work. Let's try it. Run the app. type in some numbers, type in 42 in one text area and 100 in the other text area, and this thing will sit here forever, waiting for an event. The event I choose is the click event on the button. I click on the button. In the first label, it puts in 142, the sum of those two numbers. We've demonstrated how to do event handling on the click event of a button. Your next step would be to learn about other events and other controls and build more complex graphical user interfaces. Close the app, back to Eclipse. Before we finish, I want to mention that everything we did worked, but we oversimplified it because this is an introduction to GUIs. One of the things that we should definitely do on our way to more robust production-ready code is to run our GUI in what's called a thread. And that thread is special because it's dedicated to the graphical user interface in our app. All we have to do then is put all of our code in this method called invoke later. And then we're creating an instance of what's called a runnable class. I'm not going to go into any more detail here. This involves threading and things that we haven't discussed yet. But I want to just throw out the concept because it is very important down the road that we think about writing code that is thread safe. In other words, it can run in parallel with itself. And we'll do more of that later. But I just wanted to expose you to the concept right now. Finally, another thing that we will do more of way later, not in this video, is think about how to make this easier. Because we did a lot of trial and error, we did a lot of programming by hand, it worked well, it was convenient. We only have how many controls? 2 labels, a button, and 2 text areas. We have 5 controls. And we used the default layout manager. We didn't change any colors. We didn't change any properties, shadowing, background, foreground. We didn't build any complex things like checkboxes or drop-downs. All of this is definitely available to us programmatically. We could sit here all day and probably make a living, not a good one, writing swing code this way. But there are better tools to do more advanced work. The concepts still apply. We have events, we have controls, we have containers, but when you get to more complex user interfaces, you want some other tools than just trying to write everything by hand and hoping it looks right. One tool that you can use to make everything look right is called Scene Builder. This is a Java tool. If you're told to create a Java GUI, this is a tool that you should consider because it is a visual tool. Instead of writing things in Java and then running them to see how they look, you can lay out all the controls on the frame visually, move them around, change the size, change the labels, change the colors, add your drop-downs, change your tab order, and then save it. Then go back to Eclipse and then add code to the events. You're separating then the GUI design with the coding behind the events thrown off by that GUI. Now we're not going to do this. One reason we're not going to do it is because you'd have to install it, and sometimes that's problematic. I just want you to know that it's unlikely that you will do production code simply by writing a whole bunch of controls and adding them to containers and then going back and forth, trial and error, trial and error. Keep that in the back of your mind, scene builder. Also, if you move to a different development platform, a Python or a C#, there are other graphical visual tools for developing your GUIs. So it wouldn't be called Scene Builder, it would be called something else. In C#, a popular tool is provided in Visual Studio, which is really nice for developing graphical user interfaces. And I just want you to know that that's out there. Don't leave this video with the impression that we write everything by hand, because we don't. So hopefully that was helpful. Make sure that you study this code. Make sure that you understand the concepts of containers and controls and layouts and events. And you are able to write these basic little programs as we have discussed here. Thank you.